Good morning everyone. Welcome back to our channel Study with Adu. So this is the part 3 of all organic chemistry reaction. So in the last class we stopped with phenol. So now we have ether left. But the thing is that the questions from the portion ether is very less for the exams. Normally when we check the questions from aldehyde ketone has a high weightage. Comparatively aldehyde ketone and amines also have high weightage compared to ether's part. So ether's part will be doing at the end, like after amines, and it's just a short part, just about Williamson synthesis and that KINAOH reaction, something like that. So that we'll be doing at the last. So now we'll be starting with the reactions from the chapter aldehydes and ketones. Aldehydes, ketones and carboxylic acids. Look, learn from NCERT. Many of the children are learning beyond NCERT. Look, in JEE means they can only ask 30 questions. In that 30 questions, if they are going to ask beyond the scope, then why they give the syllabus? So they will only ask in scope, like inside the syllabus. So learn the things from NCERT and the syllabus, from the syllabus. Okay, without much ado, everyone, please like our video, subscribe to our channel, share to your friends, and comment your doubts, opinions, suggestions, etc. down the video. For sure I will be replying to it. So without much ado, let us start with the reactions. First of all, in this chapter, in every chapter we should start with preparation. So here first is preparation of aldehydes and ketones. Common method for preparation of aldehydes and ketones. 1 second, I'll return back now. Yes, so we are first dealing with the common method for preparation of both aldehydes and ketones. Look, in your textbook it's written that find from that chapter, find from this chapter, find from that chapter. It's there in unit 1, unit 2, because different places. I will give all that reactions here, so you don't have to search each unit and take time. First one is by oxidation of alcohols. This thing we learnt in alcohols chapter. What? Using CrO3 or using PCC, right? So you can use RCH2OH, primary alcohols, using PCC or CrO3, anhydrous CrO3. What you can do? You can convert it into RCHO, primary. If it is secondary, that is RC double bond RCOH HR dash, you can use anhydrous ketone to form ketones. From secondary alcohol, use anhydrous CrO3, you get RC double bond O R dash, ketone is formed. So this is the reaction. This is the reaction. Okay, yes. Now second method, that is by dehydrogenation of alcohols. This reaction is also there in alcohols chapter. Which one is that? That is RCH2OH on the surface of metal, that is copper, and very high temperature 573 Kelvin, we get RCHO. If it was secondary, that is RC double bond RCOH R dash, this compound and Cu 573 Kelvin, what we get? We get RC double bond OR dash. Now it was if it was tertiary alcohol, that is R double dash R dash OH and copper and 573, what happens? We get an aldehyde or a ketone? No, we get a alkene. According to Zaitsev rule, we get an alkene. Okay, we get an alkene. So this is the reaction. Now third one is from hydrocarbons. In hydrocarbons chapter, you learned one of the most important reaction from alkene, that is ozonolysis. Using ozonolysis, we can prepare what? Aldehydes and ketones. Very simple. We just take an example and do it. That is I'm taking CH3 CH double bond or CH2. Into this I'm adding ozone. So what I get? An ozonide. I get ozonide. That is the intermediate ozonide. That is CH3 CH. The double bond will be split like this. Remember, CH2 O. This is called a ozonide. That is the intermediate name is ozonide. Into this ozonide, if we are adding Zn plus H2O, zinc plus water, what happened? This thing, it will break like this. It will break like this, and we get CH3 CHO plus CHO HCHO plus HCHO. So we get acetaldehyde and formaldehyde. So accordingly, if you do the ozonolysis reaction for any other double bond compound, you will get the same. Use this method. Draw this thing and cleave it like this. This part one compound, this part another compound. Okay. So this is the ozonolysis. Now from hydrocarbon itself, there is another method, that is from alkynes. From alkynes. This is from alkene. Now from alkynes, that is hydration of alkynes using mercury, HgSO4, mercury sulfate. Okay, hydration of alkynes. Take the compound, that is CH triple bond CH, and add H2O. In presence of HgSO4 and H2SO4, a temperature 300 Kelvin, that is 333 Kelvin. Okay, we get CH2 double bond CHO. Very special reaction, right? Yes. Here one bond break, and we get one second. Sorry. Something went wrong. Yeah. Here what compound we get is that, not this one. Here what one bond will break, and this will go and attach with OH like this. So what happened? The compound we are getting here is CH double bond CHOH. This is the compound we are getting. Now you know that there is something called 1,3 tautomerism, 1,2 tautomerism and all. So isomerism happen, that is tautomerism happen. Keto-enol tautomerism. This is 1, 2, 3. 1,3 tautomerism is happening here. Nothing happened. This double bond will fall here, and this hydrogen will go and join this carbon. So we are getting CH. No, not this carbon. Sorry. Hydrogen will go and join this carbon. That is CH2CHO. This is the compound we are getting. This is a aldehyde. Or this is an aldehyde. Okay. So this is the next method. Now we were discussing about the method for preparation of both aldehydes and ketones. By this method, ketones can also be prepared, taking respective alkynes. But now we are talking about exclusive methods, some exclusive methods. So now we are talking about exclusive methods for preparation of only aldehydes. Preparation of specially aldehydes. Aldehydes. What are the methods? Take first method is take acid chloride and add H2 palladium BaSO4. This will be converted to corresponding aldehyde. This is a special method. Here H2 PdSO4 is the reagent. This method is called Rosenmund reduction. That is, I will write it very boldly. This method is called Rosenmund reduction. Very important. Very important method. Name. That is Rosenmund reduction. Okay. Yes. Rosenmund reduction. Now second method, take a cyanide and into that we are adding tin chloride and HCl. We get imine as a what? Intermediate. That is RRRCH double bond NH as the compound, or as the what? As the intermediate. If we hydrolyze this imine, this is called imine. This compound is very important, imine. Many places we will see this. This thing we will be seeing in the same chapter itself. Okay. And if we hydrolyze this imine, we get RCHO, aldehyde. This method has a special name. This method is called Stephen's reaction or Stephen's reduction. Stephen reaction or Stephen reduction. Okay. Yes. Important. Now, instead of using this SnCl2 HCl and all, I can directly convert RC into RCHO using dibal H. Use dibal H, then hydrolyze it. H2O. I can convert it. The thing is that if I am using dibal H, it will not attack. It is like PCC. It will not attack double bonds. That is isolated double bond. If it is in conjugation, it may attack, but if it's isolated, it will not attack. That is, an example is given in a textbook. CH3, CH double bond, CH, CH2, CH2, CN. Into this I am adding one dibal H and 2 H2O water. We get CH3 CH3 not one second CH double bond CH CH2 CH2 CHO. We get this compound. Here the double bond is not attacked, so dibal H will not attack double bond. It's a weak reducing agent. Okay, it's a weak reducing agent. Okay. Now next reaction. If I need, I can also reduce esters to aldehyde. That is, take an example, CH3 CH2 9 times or 9 or 8 or something like that. Any compound, any ester I am taking, OC2H5. It is an ester also. I can use dibal H as a reducing agent, good reducing agent, but weaker than LiLH4. Okay, dibal H and H2O. What happens? Very simple. We get CH3 CH2 9 times CHO. We get this part as aldehyde and the rest part we get as alcohol. We get it as alcohol. It's not given in a textbook, but we'll get it as alcohol. Okay. Yes. So this reaction is also preferable from ester. Now some reactions for aromatic aldehydes. First one is first method. Take benzene. Into this add CrO2Cl2, chromyl chloride and CS2 medium. What happens is that this intermediate is very important. We get a chromium complex as an intermediate. What is this complex is very important. We should take toluene. We are taking toluene. Sorry, I told benzene we can't take. We should take toluene and we are adding chromyl chloride in CS2 medium. What happened? We get an intermediate, that is CrO2 O2 HCl2 Cr O2 HCl2 twice. Here CH is there. So CH Cr O2 O2 HCl2 twice. This is a chromium complex we are getting. Now if we hydrolyze, that is H3O plus. Hydrolyze this complex we get benzaldehyde. Okay, this method with the chromium component has a special name, very important reaction. The name is Ettard reaction. This many named reactions are there in this lesson. So this reaction is called Ettard reaction. Okay, yes. Now next one. Now second one. This reaction I'll just tell it fastly because this and all never asked in the examination. Not that important. They may ask, don't skip it, but don't learn it very thoroughly. Now next one is we are taking toluene, we are taking CrO3, anhydrous, not anhydrous CrO3, just CrO3, and we are taking an acid anhydride and at 273 to 270, that is ice cold temperature, 283 Kelvin. If we react it, we get once again a complex, that is CHOCOCH3 twice. And if we hydrolyze it and heat it, we get CHO. This method is called no specific name and all, just a method using chromium oxide or CrO3. Here what we are using, CrO3 and CH3CO twice O. The thing is that just learn this intermediate, that is OCOCOCH3 twice. This intermediate you learn. Okay, yes. Now next, the third method for aromatic aldehyde, that is side chain chlorination. CHLO, okay. Chlorination and hydrolysis. Very simple. Just we'll take toluene. This and all not that important. Take toluene, add Cl2 in presence of Hme, that is free radical mechanism. So we get benzylic haloalkane. Into that add warm water 373, that is boiling water. What happened? We get benzaldehyde. This is important. It's not important, just learn it. Side chain chlorination and hydrolysis. Now 4. This is an important named reaction. The name of the reaction is not just Getterman. Just Getterman reaction was there in amines chapter and haloalkane haloarine chapter. That is adding copper plus HCl into what diazonium salt, we get what corresponding haloarine. This is Getterman. Only one N is there, it seems. Koch reaction. Here Koch is extra. The same is there. Wood's Fittig reaction is there. Wood's Fittig reaction is for one haloarine and one haloalkane. Just Fittig reaction is for biphenyl, 2 haloarines, right? So this is Getterman-Koch reaction. This reaction, important thing is it's a thing. Here we are not taking toluene, we are taking benzene. That's very important. Then carbon monoxide HCl and anhydrous AlCl3 or CuCl. Anything is preferred. A Lewis base. CuCl. We get aldehyde. Benzaldehyde. So this is the preparation of aldehyde. Benzaldehyde from benzene, not toluene, benzene. Okay. This was a important. This is an important method. This is an important method. Now we told specific methods for aldehyde. Now ketone is add. So we should tell about ketone too. So now we have special method, that is unique method for preparation of ketone. Here in this chapter, many preparation method is there. That's a problem. Reaction is also there. Preparation method. This is one of the longest chapter in this NCERT textbook. Yes, preparation of ketone from acyl chloride. What we should do is that we are taking a Grignard reagent, and into that we are adding cadmium chloride. What happens is that we get R2CD, rearrangement happens, R2CD plus MgXCl 2 times. Okay, now this R2CD aside now this R2CD is taken, and into this we are adding the acyl chloride or acid chloride. Okay, that is R dash C double bond or Cl. That is 2 we are taking, because here R2 is there. Now what happened? We get 2 R dash C double bond O R plus once again we get our catalyst, that is cadmium chloride. So this reaction can be directly written as RMgX plus R dash C double bond OCl 2 gives us no need of 2, right? Yeah, we need 2 R dash C double bond O R plus MgXCl twice. So we can write this reaction directly like this. Nothing. If we react Grignard reagent with acid chloride, we get what? Corresponding ketone. That's the thing. Now next, second method, that is from cyanides or from nitriles. That is cyanide. So we are having a cyanide, that is RCN. Into this I am adding a random Grignard reagent, that is R dash MgX. Now in ether medium, what happens is that this R is there, this C is there, double bond. Look, here the bond is like this, triple bond is there. 2 bonds will be still attached to N, and this N will be attached to MgX, and the rest will be attached to the next R dash. Okay, R dash. Now what we get? Now if we hydrolyze H3O plus hydrolyze, we get a ketone, that is RC double bond O R dash. So we get a ketone. So 2 methods using Grignard reagent. Grignard reagent is an important thing while preparing yes, aldehyde or ketone. Yes. So accordingly we get the thing as per the Grignard reagent we are using. So from nitrite, now from acyl chloride over from nitrite. Now we are having from benzene or substituted benzene or substituted benzene. Yes, take a benzene or a substituted benzene. This is a very simple reaction. This is called Friedel-Crafts acylation. Into this we are adding RC double bond or Cl in presence of anhydrous AlCl3. What happens? Friedel-Crafts acylation happen. That's what is going to happen. We get C double bond O R. This is the reaction. This is the reaction. Very simple. Over. With this preparation of ketone, aldehyde, both of them, everything is over. Now we are moving on with the here their physical properties important. We can just read, especially the boiling point order. That's only the important thing. Now chemical reaction. What is important in chemical reaction? First of all, understand one thing. They are telling many random things here. Just understand. Ketone is less reactive. Compared to aldehyde. Understand this thing. This is very important. That's what I have to tell you. Okay. Yes. Now first it is nucleophilic addition reaction. Why addition reaction? Because double bond, because it's C double bond. Double bond, if it's there, always add. Okay, double bond, if it's there, always add. That way nucleophilic addition reaction is shown by aldehydes and ketone. Nucleophilic addition reaction. Okay, how it is formed? Different things can be nucleophilically added. Okay, different things. Look, first thing, I will just tell about some important things. We'll just add it nucleophilically and we'll just end the discussion because we have to make it faster. First thing is that if I'm taking a aldehyde or ketone, that is this thing, plus I'm adding HCN into it. HCN. In this, Cn minus is the nucleophile. What happens here is that, first of all, in a nucleophilic addition reaction, in this, always we get an intermediate. Here, what is the intermediate? The intermediate is O minus C, O minus and Cn. This is the intermediate. This is a tetrahedral intermediate. Okay. Yes. Now if we hydrolyze H3O plus, what happens? We get OHCN. This is the compound we are getting at last after addition. This compound's name is very important, and this compound production, that is, you should understand that when we add HCN to what aldehyde or ketone, we get this compound, that is OH and CN. This compound's name is cyanohydrin. Very important, cyanohydrin star. Okay. Yes. Now next important compound is into C double bond O. If you are adding NaHSO4, that is sodium bisulfate. If you are adding this, what we get is the same way you rearrange it. O. Okay. Here O minus is there, so Na plus. Here HSO4, HSO3. So at last what is forming? Here hydrolyzation happening. So at last we get COH plus SO3H. This is compound is a bisulfate addition compound. Okay, this compound we are getting. Now into aldehyde or ketone. If I am adding Grignard's reagent, that is RMGBr, what we get? Do it the same way. We get OMGBr, O minus plus R. This thing was called adduct, and this was one of the method of preparation of what? Alcohol. You remember? And if you are hydrolyzing this thing, we get C. Once again, we get C OH R. We get what? Respective alcohol. Remember the reaction? Yes. This is addition of Grignard reagent. Now addition of alcohol. So into an aldehyde or a ketone, I'm adding alcohol, and HCl gas is also added with it. Why are we adding dry hydrogen chloride gas? Because it helps in protonation. The reason is helps in protonation. Just learn the reason. Just learn it. Just by heart it. At last moment, by hearting is the only thing we can do. By heart it. Okay. And into this what happens? We added ROH. Now we are getting Now we are getting a compound. Now what we are getting, you know, we are getting a new compound, that is C okay, one second. First of all, we will consider aldehyde, then we will consider ketone. So we are first we will consider aldehyde. So if it was aldehyde, we will get R, C, H was here, O was here, like this. Now what happened? Now after this reaction we have R, CH is there like that itself. O will be splitting, one will become OR dash and the other one will become OR dash from one from OH and one from O, and R dash from this thing, R dash from the, not R dash from this, R dash from the alcohol. So we get this compound. This is called hemiacetal. This is the intermediate here, hemiacetal. Now if you hydrolyze, or if you add ROH, one more ROH if you are going to add, you know that the compound was like this, that was here one OR dash and here one OH. This H also will be replaced by this R dash. So at last we get the compound as something like this. This compound is called acetal. Hemi means half, only one R was replaced. Here both the H is replaced by R dash. So this is called acetal. Acetal. Okay. Yes. Now next compound, that is RC double bond. Now if we are considering ketone. If you consider primary alcohol, no reaction will happen. If you take a not primary alcohol, if you are considering monohydric alcohol, no reaction happens. So we should take dihydric alcohol, that is 2 OH group alcohol with 2 OH group. If you are taking this, what happened, you know? To this OH, attach these two group, these two group, that is RCR. Okay, O CH2. Remove this hydrogen. Okay, remove these two hydrogen. Then attach it like that. O CH2. Okay. This is called ethylene glycol ketal. This is called a ketal. Other one is called acetal. This is called ketal. Okay. Yes. So this is about the addition reaction. Now into a carbonyl compound, that is aldehyde or ketone. I'm adding an amine. Ammonia or ammonia's derivative. That is NH2Z. This Z can be H, this Z can be OH, this Z can be DNP's derivative, this Z can be what, simply some R. Depends upon because derivatives of ammonia. Okay, if I'm adding this, what we are going to get is C double bond NH2Z. This is what we are going to get, plus H2O. This reaction is important because this reaction helps us in identification of aldehydes and ketones. That is 2,4-DNP test. So now you know that if I'm taking a compound like this and I'm adding ammonia, what will be the compound I'm getting? C double bond NH2. Will NH2 come? No. NH. Now I'm taking an aldehyde or a ketone and adding what? An amine, that is RNH2. What will I get? CO will be going double bond N R. This is the compound I'm getting. This is called a substituted. This compound, do you remember in Stefan reduction? We call it imine. So that's why I told in this lesson as well we will be dealing with this imine. Yes, this is called substituted imine. Okay, perfect. Now I am taking C double bond O. Into this I am adding NH2OH. that is hydroxylamine. Here we get a special compound. The name of the compound is very important. That is oxime. Okay. Yes. This oxime can have geometrical isomers. Geometrical isomer, that is cis or trans. Anything can have geometrical isomer. Okay, don't forget. Now phenylhydrazine, that is C double bond O NH2, not NH2. Now next one is hydrazine, that is NH2. This compound is called hydrazine. Now if I am adding it, we get C double bond N NH2. This is called hydrazone. This name is very important, the hydrazone. Now I am taking C double bond O. I am adding phenylhydrazine, that is NH2 NH and a phenyl group. Okay, this is called phenylhydrazine. The product we get is called hydrazone. Okay, so here what happens, C double bond NH. Okay, this is called phenylazone, hydrazone. Okay, yes. Okay, now next one is very important. This is called the 2,4 DNP test. That will be there for your practical exam. Identification of what? Aldehyde or ketone, carbonyl compounds. Okay, to this I am adding NH2 N. 2,4 DNP full form was 2,4, that is 2,4 dinitrophenyl NO2 phenylhydrazine. The compound that we are going to get after the reaction is called 2,4 dinitrophenylhydrazone. N. Here NH is there. NH. Accordingly NO2. This is called 2,4 dinitrophenylhydrazone. Now carbazone. Now we are adding carbazide. What is carbazide? That is C double bond aldehyde or ketone NH2 NH C double bond O NH2. This semi carbazide, not azine, carbazide. Here it is carbazide. Now after reaction we get NH C double bond O NH2. This compound is called semi-carbazone. Okay, yes. And this 2,4 dinitrophenylhydrazine, the color of this compound is orange red. This is very important. This can be asked for the exam because practical chemistry is a part of the portion. Okay. So these are the important addition reactions, nucleophilic addition reaction. Now next to 2 reduction reactions. Very simple. Reduction to alcohol. We can reduce this aldehydes and ketone to alcohol and also to the next step down, that is hydrocarbon. To alcohols, if we need to reduce, it's very simple because preparation of alcohol from aldehyde or ketone. Do you remember that? There we used BH4 or lithium aluminum hydride, etc. And we reduced aldehyde, that is RCHO. If you use NaBH4, what did we get? We get RCH2OH. Remember, that's the thing, reduction to alcohol. If you need to reduce to hydrocarbon, respective hydrocarbon, that is aldehyde, that is benzaldehyde to benzene, or what acetaldehyde to ethane, etc., etc. How can we do it? There are two methods. First one is called Clemensen reduction. This reduction is take the carbonyl compound and reduce ZnHg HCl. We get CH2 plus H2O. This is called Clemensen reduction. CH2 plus H2O. Now another method is also there. This is also important. That is Wolff-Kishner reduction. This is a two-step process. That is, first of all, we'll take the carbonyl compound and react it with the NH2, that is hydrazine. Okay, and water will be removed and we get this compound. What is this compound? Hydrazone. Yeah, into this hydrazone we are adding KOH in ethylene glycol and heating. So we get the corresponding hydrocarbon plus nitrogen gas. Here we got water, here we are getting nitrogen gas. Okay, yes. Now next reaction, it is what? Oxidation reduction. The next reaction is 3 oxidation. Now we did reduction, now we are going to do oxidation. That is very simple. Take aldehyde and just oxidize it. Oxidation will show with the symbol. We get what? The corresponding acid. Aldehyde differ from ketone in their oxidation reaction. Aldehyde are easily oxidized to carboxylic acid on treatment with common oxidizing agent like nitric acid, potassium. So nitric acid, we can use anything to do this reaction. Nitric acid, potassium permanganate, potassium water, dichromate, that is K2Cr2O7. Then even mild oxidizing agent like tolerance reagent. We can use any of the following to convert aldehyde to acid, not ketone. Aldehyde, tolerance reagent, Fehling solution, etc. We can take. But ketones are generally oxidized under vigorous conditions only. Okay. Ketone vigorous condition only they undergo. Vigorous condition only they undergo oxidation. Vigorous condition. What we get if ketone undergo oxidation? We'll just check. Vigorous condition they did undergo oxidation. We get RCOOH plus one second. Yeah, we'll write it in another method. Okay, look, we'll write it like this: R dash CH2 C double bond O CH2 R. If this was our ketone and we did vigorous oxidation, we can get two compounds. That is, we can get RCOOH plus R dash into CH2 COOH. This we can get, or we can get R dash COOH plus R CH2 COH. Anything is possible. We get two carboxylic acid as the product when ketone is oxidized. But we need vigorous condition. Aldehyde just need mild oxidation agent. Toluene and Fehling itself will oxidize aldehyde. But ketone need vigorous condition. Now we are going to talk more on tolerance test. Tolerance test given by only what? Aldehydes. aldehyde. So this is a distinguish test. Distinguish test. Guish test. Important. What is tolerance reagent? Tolerance reagent. Ammoniacal silver nitrate. This is the tolerance reagent. What is the end point? If we add some tolerance reagent into an aldehyde, the end point is a what? Shining silver mirror. That is, you have a test tube. Once again, why this test tube is looking this? So this is your test tube. You think this is silver color. You have silver color things stuck to your test tube. So you can see shining silver mirror if it is an aldehyde mirror. The reaction is given here, that is very important. It's RCHO plus 2AgNH3 twice NH3 twice plus 3OH minus give RCO minus. Here acid is formed plus 2Ag plus 2H2O plus 4NH3. Okay, yes, over. This is the reaction. Now second test is Fehling's test. This is also given by only aliphatic aldehydes. That is benzaldehyde and all don't give. Aromatic aldehyde don't give, only aliphatic aldehyde give. What is Fehling's solution? There are two Fehling solutions, that is Fehling A and Fehling B. You should learn what is Fehling A and Fehling B. Fehling A is a copper sulfate solution. Fehling B is Rochelle salt or what is Rochelle salt? You should learn, that is potassium tartarate. It is the Rochelle salt. That is Fehling solution A and B. What is the end point? It is a reddish brown PPT. Okay. Now the reaction is, we are having the aldehyde, aliphatic aldehyde. This 2Cu2 plus, that is Fehling solution, 5OH minus. We have the corresponding acid plus C. To get the acid, you should hydrolyze this stuff. Acid. This Cu2 is the brown. They can ask, what is the brown precipitate? That is Cu2. What is the silver mirror? That is silver itself. But what is the brown precipitate? That is copper oxide. That is the brown precipitate, Cu2. Okay. Copper oxide plus 3H2O. Very important. Very important. Okay. Yes. Next one. We have another third test, like mild oxidation. Like these three tests, tolerant test, Fehling test, and then iodoform test. Next test I am going to tell. These three tests are for mild oxidizing agent. Tolerant is a mild oxidizing agent. Fehling is a mild oxidizing agent. NaOX is a mild oxidizing agent. All are mild oxidizing agent. So now next test is aldehyde and ketone having at least one methyl carbon. Methyl group. One methyl group. This is the thing important. For what? This iodoform test. What is this? One methyl group. So what's the reaction? Look, I'm having a aldehyde or ketone with one methyl group, that, and I'm adding NaOX. Okay, the reagent that we needed. We get C double bond O ONA plus CHX3. Here the methyl group will be replaced by ONA. The CHX3 is the iodoform. That's the precipitate. The color of iodoform is what? Iodoform. What's the color of iodoform? Yellow. Yes, iodoform is a yellow solid or a yellow precipitate. Yellow precipitate. This is the reaction. So we'll do an example for this reaction. That is HCH3 double bond CCH3 C double bond OCH3 give NaOCl. We get C double bond O CCH3 HCH3 C double bond O, the methyl ketone will be replaced by ONA plus CHCl3. But usually we should do it with what? NaOI, so that we get the iodoform. CHCl3s don't have a specific proper color, but iodoform has a good color. That's the reason we prefer that. Now next reaction is 4. Now oxidation over. Now we are going with the next set of reaction, that is reaction due to alpha hydrogen. If an aldehyde or a ketone have an alpha hydrogen means, look, CH2 C double bond O CH3. Yes, this is called the alpha carbon. Is this called the alpha carbon? No. Alpha hydrogen means the hydrogen next to the carbonyl carbon. That is this or this. Both are next. This is called this hydrogen. That is here. This hydrogen can be called the alpha hydrogen. If a aldehyde or a ketone have the alpha hydrogen, we know that there is a specialty that when a base is coming, the alpha hydrogen easily leaves the compound, or alpha hydrogen easily escape, or dehydration takes place. Okay, so that way, if alpha hydrogen is there, dehydration reaction is possible. So double bond formation is possible. So with this, we are coming to our next set of reaction, that is aldol condensation reaction. Take an aldehyde or a ketone with alpha hydrogen. Alpha hydrogen important. Okay, alpha hydrogen. Into it add dilute NaOH, not concentrated, or dilute NaOH. So what happened? You can take two of them. So first of all, if you are taking two of them, write it like this: CHO CH3. How to write it? One group CHO CH3. Here alpha hydrogen. So write the next carbonyl group below the alpha hydrogen group like this. Okay. Now what we do, right? We form a double bond. Remove the oxygen, form a not a double bond. Remove this oxygen, form a single bond. Remove this oxygen, form a single bond. Put one H. So we get CH3 CH. Not like that. One second. Sorry. Yeah, we are having like this, right? Okay. Right. Okay. Take this here. And as this bond is formed, one hydrogen from here come and join here. Okay. Nothing. You do what you know. Okay, one second. I just tell. Okay, we are having something like this. CH3. Form a bond here. Minus one hydrogen from this and add it to this H. This O. So we get CHOH here, CH2 CHO. This is called aldol. Now heat this compound. This OH and a hydrogen from this compound will leave as what? Minus H2O, water. And there is a bond extra standing here, sad bond. This will be falling here. So we get CH3 CH, double bond CH, CHO. This is called aldol condensate. Aldol condensate. The double bond compound is called aldol condensate, not aldol. The compound with the hydroxyl group is called the aldol, and when it is condensated or when the water is removed only, it is called the aldol condensation product or aldol condensate. Okay. Yes. Now we can take any mild base. Any mild base we can take. Not only dilute NaOH, we can take BaOH twice, dilute KOH, anything we can take. But it should be dilute or very weak base. So now we are taking an example of what? Ketone with the alpha hydrogen. First of all, check. Yes, there's alpha hydrogen. So if we saw alpha hydrogen, cut this two, and adjust. I will adjust the compound as I need. Cut this two, and I'll write the C double, the carbonyl carbon under the alpha hydrogen. That is, I'll write like this. Okay, CH3. Okay, perfect. Now into this we add the dilute. What we'll add, not dilute, because first of all barium hydroxide is very weak, so why dilute? BaOH twice we added. Now what happens is that I'll write it like this. Form a bond here, decrease one hydrogen from here, let that hydrogen go and join here. So we get CH3 COH CH3 CH2 C double bond O CH3. Now this is called aldol. Now to condensate it, heat it. If we heat it, what happens? This will go, and one hydrogen from here also will escape as water. Now double bond will form. So we get CH3 C double bond CH plus C double bond O CH3. This is the compound. This is the aldol condensate. So now we will be doing some aldol condensation reaction. Look here. This atom, this is also acetone. The below one also acetone. The above one is also acetone. Right? That is, two acetone are reacting. There can be cross reaction also. That is example for cross reaction. That is, I can take CH3CHO, that is this thing, and I can take acetone. These both compounds can be taken and crossed. So there is some possibility that CH3CHO come on top, C double bond or CH3. This can happen because alpha hydrogen below carbonyl carbon, or this combination can also happen. Here also there is alpha hydrogen. Okay, this can come top, here alpha hydrogen, so the corresponding CHO group come down, CH3 happen. So there are two possibilities. So both the possibility also happen. Here I am doing both the steps together, that is condensation plus removal of this thing. So what happened? We get CH3 C double bond CH2 CHO, here CH3. This is the compound we get here. Now if we do this here, NaOH plus heat, what happened? We get CH3 C H double bond CH2 C double bond O CH3. We get this compound. This compound's name is 1 2. Okay. 3-methyl 1 2 3 4, right? But 2-ene-1-al. No need of 1-al and all. But 2-enal. Okay, this compound can be named as 1 2 3 4 5. So okay, Pend 3 in 2 on. Pend 2 in on. Okay. Pend 3 in 2 on. This is the compound. Okay. So this is the concept of cross aldol condensation. Now you can do different samples with different compounds and try. Now sad reactions. Sorry, other reactions. Some miscellaneous reactions. Look, all the compounds are now really sad. They are depressed about their condition. Some compounds, not all the compounds, some compounds. Look, benzaldehyde. We were talking about special method for preparation, Ettard reaction, Getterman-Koch reaction, etc. Many special reaction was there. But this compound don't have an alpha hydrogen. No alpha hydrogen. Because here already the bonds are filled, right? No alpha hydrogen. Formaldehyde. That is a very important compound. Formaldehyde, the basic aldehyde. The problem for this also is that formaldehyde is a very sad compound. One second. Formaldehyde is a very sad compound. One second. That is C double bond O H. It don't have a what next carbon itself. So how it can have an alpha hydrogen? Depressing compounds. These two compounds. There are some other compounds also like this without alpha hydrogen. So for this reaction, there was a scientist called Cannizzaro. He formed a reaction for this molecules without alpha hydrogen. He formed a reaction called Cannizzaro reaction. What's the reaction? Take the compound without alpha hydrogen, depressing compound. Usually for aldol condensation and all, we take two molecules. So here also you take 2 molecules and add alcoholic KOH, or not alcoholic, you can do concentrated. There and all we used water. We just used dilute NaOH in aldol condensation. Here look, no need of aldol condensation. We are using very concentrated KOH and heat it. Here what happened, you know. One will be converted to alcohol. Other will be converted to what? Salt. Potassium salt of carboxylic acid. Okay. So first one. Just take the first one, that is this will be converted to CH2OH. Second will be converted to HC double bond OH. No, it's a potassium salt because we are using KOH. If we hydrolyze the salt, we get acid, but we are getting here the salt itself. This thing. So this is the thing formed. Now if we are using benzaldehyde and we are doing the Cannizzaro reaction, that is 2 molecules of benzaldehyde plus concentrated KOH. Try it. What happened? Yeah, one will be CH2OH plus the other one will be potassium salt, that is C double bond OK. This is the compound. We get this compound. Here we get CH3OH. Everyone forgot. Yes. These are the 2 compounds we are getting. So this is Cannizzaro reaction. Compound without alpha hydrogen when reacted with concentrated KOH form corresponding alcohol and potassium salt of carboxylic acid. Perfect. Now the last reaction from the chapter, aldehydes and ketones, carboxylic acid, will be starting in the next session only because it's already 1 hour 5 minutes. Oh my god. So next one is electrophilic substitution reaction. Yeah, this is the okay. We are taking for electrophilic substitution reaction for aromatic. Only for aromatic we are speaking here. Because only aromatic will show electrophilic substitution. Others will not show. Because of resonance they are showing. Aromatic aldehyde. That is benzaldehyde. So look, benzaldehyde. I am taking the compound. There is a basic theory that I wanted everyone to learn. If this compound, look, this is a carbon. If this carbon is attached to more electronegative, if any atom which is more electronegative than carbon, oxygen is more electronegative, more En, more electronegative than carbon, always understand this group will be deactivating and meta-directing. Understand this. Another example for the same is, take this. You have C double bond to OH, carboxylic acid or benzoic acid. Carbon, look, carbon. Is it attached to any electron? 2 electronegative, more electronegative. So if carbon is attached to more electronegative group, understand this is a deactivating meta-directing group. Okay, you understood. So you can understand that the benzaldehyde is a deactivating meta-directing group. So it is a meta-directing group, not orthopara. So this is a deactivating meta-directing group. Anyway, it's a meta-directing group. So this compound will not show Friedel-Crafts reaction. Friedel-Crafts reaction is not shown by benzaldehyde. Here we are only going to learn one electrophilic substitution reaction, that is nitration, HNO3 and H2SO4. And where does nitrogen go and attach, NO2 go and attach? Beta position. Para position. Oh, para position is the major product. No, it's go and attach at the meta position because benzaldehyde is a meta-directing deactivating group. Okay, so meta position. This is the product. Meta-nitro benzaldehyde. Okay. So by this, all reactions of aldehydes and ketones come to an end. 1 hour just for this one chapter, that is aldehyde and ketone. Learn well. This chapter is important. This chapter, many named reactions they can ask. Many named reactions. So it's important. Okay. So I'll come with the next part, that will be carboxylic acid, and if possible amines too will be completed in that part. Thank you.